Okay, now we already found that the period depends on the length, and we have a table of length versus the period, and we learned that the relationship between the length and the period is defined in terms of this equation. The period is equal to 2 pi times the square root of the length over g, where g is the acceleration due to gravity. Okay, now if you plot a graph of period versus length, you are not going to get a straight line here. What you're going to get here is the curve pertinent to the graph of the y-axis versus the square root of the x-axis, which will be in the form of a curve. Okay, so how can we get a straight line equation out of this nonlinear equation? The way to do that is to get rid of the square root. And in order to get rid of the square root, you have to square the two sides of the equation, because the square of the square root will remove the square root. So now if we square the equation, we'll be squaring the left-hand side and the right-hand side. So the square of t is t squared, the square of 2 pi is 4 pi squared. And now the square root of L over G, this means the square root of L over the square root of G. When you square the square root will be removed. So the square of the square root of L is L, which is the length. And the square of the square root of G is G. And I'm going to place G here. It's the same thing, L over G. 4 pi square L is the numerator and G is the denominator. Now, is this an equation of straight line? Let's look at the equation of straight line here. The general equation of straight line is y equal the slope. I'll use m here for the slope, times the x values, the x-axis, plus b, where b is the y-intercept. Now here, I'll be taking t squared as our y-axis and L as the x-axis, okay? So the graph will be t squared, the period square, versus L. Now, will that yield a straight line? This depends on the value of 4 pi squared over g, because 4 pi squared over g will be the slope here. If we project the equation of our graph onto the general equation of straight line, the equal sign here will match with this equal sign. Length is the x-axis, and the formula here between the x-axis and the equal sign is the slope. So this is the slope here. So the slope is equal to 4 pi squared over g. Now, is 4 pi squared over g a constant? The answer is yes, it's a constant, because 4 is a constant, pi squared is a constant, and g is a constant. G is the acceleration due to gravity, which is constant as long as you are on the surface of the Earth. So this should give you a straight line, and the slope of this straight line is 4 pi squared over g. Now, how can we get g from the slope? So since the slope is 4 pi squared over g, we can rearrange this equation to solve for g. So here, if we rearrange the equation, you multiply both sides of the equation by g, and then you multiply both sides of the equation by 1 over the slope. This will give you g equal 4 pi squared over the slope. So we can calculate g from the slope. So what we need to do here, we need to create a table of the length versus t squared. So you have to take all the values of t and square it. You already have the values of the length. You square all the values of t, and now you can plot a graph of t squared versus L. This graph here, you should be able to get a straight line. You'll follow the steps we did in experiment number 1, graphing, to find the slope using the statistical feature on Microsoft Excel. And after you find the slope, you take 4 pi squared over the slope, and this will yield the acceleration due to gravity. Then after that, you can find the percentage error between the experimental value, which will be calculated from the experiment using the slope that we got out of the data that we collected during the experiment. So that will be the experimental value of g, and you'll find the percentage error between this experimental value from the slope and the actual value. And we know that the actual value, g, actual or theoretical, is 9.8 meter per second square. So you'll take the percentage difference here you'll take the absolute difference between the experimental value minus the actual value. Remember, the actual value is 9.8 divided by the actual value, 9.8, times 100. The 100 is in the numerator here, and this will give you the percentage error between the experimental value and the actual value. Of course, you'll be using second squared for the time and meter for the length, so that the experimental value of G will come out in meter per second square. Alright, I hope you found this video educational. Thank you.